As we all know, Europe has launched the Green Deal and wants to accelerate in decarbonizing society, and the mobility sector is an important contributor to the CO2 emissions. And so if we can electrify mobility, that would be an important contribution to the decarbonization of the European society. And in achieving this electrification, fleet can play an important role, as fleet could create the start of an S-curve. Switching between two technologies like internal combustion engine and electrified mobility typically goes into S-curves. That means that you have early adopters, but you have to create a momentum, and that momentum can be created by fleet, because fleet can also have a kickstart of the infrastructure rollout and therefore can contribute that we have the S-curve coming in sooner compared to if you would do nothing at the side of fleet. On top of achieving the Green Deal, also this is an important relaunch measure, because electrical mobility today starts to be more and more in the money, meaning that company cars have a comparable electrical car in the same range, so meaning that without additional cost we can actually have a stimulus to economy, including then as well the rollout of the infrastructure for charging those electrical cars. Well, Elia issued last year in November a study about electrical mobility and the impact on the grid, and what we did was we simulated 2030 with 1.5 million electrical vehicles in Belgium and 10 million electrical vehicles in Germany. And what we saw is by normal charging behavior of people, you would increase the peak load with 10%. 10% of peak load increase would mean actually that a lot of people would charge at the moment that prices are high, but even worse, that they would need for that 10% additional peak load, that we would have to have plants that support the system at that moment of time that typically are more CO2 emitting, and therefore the carbon footprint would become more negative. We also looked at smart charging, and if we look at smart charging, we saw that actually we got the opposite effect. There would be benefits for the consumer and there would also be benefits for society, and therefore it's very important that we focus on getting smart charging adopted at a wide scale. As a consumer, typically 90% of the time your car is parked and you only need 2 hours to charge your car for your average daily consumption. That means that it gives an important window of opportunity to shift charging at better moments of the day. So at the moments that there are a lot of renewables on the system and the prices are low. So for an average car driver, that would reduce his cost of charging by 15 to 30%. And in addition, it would reduce its CO2 footprint, CO2 footprint that went already down with 70% by moving from internal combustion engine towards electrified mobility, with 5 to 10% on top of that. In the same simulation, we looked also what would be the impact for the system. So if everybody would smart charge, they would charge more at the moment that we have excess renewables. That would then also mean for the same reference year 2013 that we would have much less curtailment, and the avoided curtailment would be the equivalent of 300,000 vehicles they're charged for a whole year. So that's quite important reduction that we would have in lost renewable integration into the grid. If we translate that then to CO2 emissions, this is an equivalent of 600,000 tons of CO2, so also a very important amount. And if we then look at the overall system cost, it would create an additional welfare of $500 million for the two markets, Belgium and Germany together. And that's because, of course, we would need less peaking plants to support the charging at the peak moments. Well, today we see already that quite some governments are taking measures to increase the attractiveness of electrical mobility, but what we see as well is that there are still important barriers. The most important barriers for a driver of an electrical car is the fact that there's still an important lack of infrastructure to charge his car. Second thing, there is a complexity in the data exchange that need to happen with those cars that often charge behind a meter. And then the last point is there need to be clear market rules on how the charging will be then invoiced to the right party. Elia launched already 2 years ago an ecosystem which is called Internet of Energy, where we had use cases around digitalization, and we used that ecosystem over the last year to have already specific use cases around e-mobility. One was around how to have an all integrated leasing contract where somebody can charge wherever they want on one single invoice. Another was around blockchain, so how do we identify a vehicle that is mobile connecting across a network. We still have a number of new use cases in the pipeline for the coming year within the same ecosystem, but we still need a lot more to make it happen that e-mobility is picking up fast, and therefore this is a call to action to everybody that is willing to contribute to this, so that they join us into that ecosystem and that we experiment so that we can deliver the best service to our clients.